So do you all understand what a line is? Good job. Then you can do this. All right. So we're going to look at all of these graphs right here. See how they're all aligned? What else do you notice about them? They are lines, but what else do they have in common? They go through the, or do you notice that? Through 0, 0? Shush. You need to understand this, and it's not that difficult. So all of those graphs represent what is called a direct variation. A direct variation goes through the origin. So that's all it is. It's a line that goes through 0, 0. As x increases, y increases. So as one thing goes up, the other thing goes up. So when we eventually get to word problems, an example would be something like this. The more hours you work, the more money you make. Do you see what I'm saying there? Like as one thing goes up, the other thing also goes up. The more hours you use electricity, the higher your bill is. Do you understand what I'm saying here? Okay. The equation for direct variation is y equals kx. K is what's called the constant of variation, and it is the same as the slope. That is the most important thing to get there. It's just the slope. That's the takeaway. If you're like, hey, I didn't listen to anything else she said, it's the slope. So, and this looks like a bunch of pages here, but this is going to go really quick. I just needed space on the paper to draw the graphs. So let's go through and do that for each of these graphs. So look at this graph. We're reviewing slope here. You need to find another pretty point, a point that's on exact whole numbers. Do you see how these are all pretty points here? Good. We went up 2 over 1. So your slope is 2 over 1 or just 2. And what's the y-intercept? Yeah, 0, 0. And so your equation is y equals 2x plus 0. You can put the plus 0 if you want, but it's not necessary. It's just nothing. It's y equals kx. K is 2 in that case. Let's try it again. What is the slope for this one? If you find all these pretty points, how much down and then over does it go? 1. Good. Only it's down, so it'll be -1. And the y-intercept is still the origin. That's like definition. That's by definition. It's going to be 0, 0. And so your equation is y equals -1x. Again, it's y equals kx. K is just the slope. Your constant of variation is just whatever that slope is. Yes, and you don't need the 1 there. Good. You can just do -x. Yeah, you're going to be okay. All right, so look at this one. Find another pretty point. Like a point that's on... So it goes through 0, 0, but you need to count the little boxes. How much up and then how much? 1 over 3. It goes up 1 over 3. Do you remember that? Where like for 2 whole months, all we did was slope. Up 3 over 7, down 2 over 6, you know, like whatever it was. All right, y-intercept is still 0, 0. That's the definition. That's what that's going to be. And so what's this equation? Yep, good. That's it. That's all that there is to this. Y equals 1/3 x. This is going to be review vocabulary that we just did in the past unit. The place where the graph touches the x-axis is called a 0 or a root or a solution. Remember, 0, root, solution, those all mean the same thing. All right. And the zeros for all of these, they are all 0 because they go through the origin. So they're all 0. And again, that's the definition, is that it's going to go through the origin. So it's actually pretty simple. Go ahead and close the Chromebook and just flip to the second page. I recorded this so you can always watch it, or I'll go over it with you again, but all you missed was the first page. So what we're going to do for these is graph the points and see if they make a direct variation or not. It means if you connect them, it goes through the origin and makes a line. So we're going to practice plotting these points. Please don't talk over me because it's actually really simple. You're going to plot -1, -1, 1, 1, and then 3, 3. And I'm sorry the axes didn't turn out like very dark here, and just do your best. So, hey guys, did you plot the points? I'm sorry, I know the lines didn't show up real dark, but all right. If you connected these, do they make a line? Yes. And would that line go through 0, 0 if you connected them? Yes. So the answer is yes. And we're going to write what K is. and k is the slope. K is just the slope. So if you connected those, 1 is your slope. Very good. You can count to 1. Nice job. Although I will say 1 does mess people up though, because it's like weird when it's just 1. So, all right, let's try it again. Stop it. -3, -4. So we're going to plot that one. 1, 2, 3, 1, 2, 3, 4. -3, -4, 0, 0, and then 3, 4. So there's 2 questions. If you connected those, would they make a line?
Yeah.
Yes. And would it go through 0, 0?
Yeah.
Yes. So the answer is yes. It's a direct variation. And k is the slope. So how much up and then how much over do you go to connect?
4.
Well, you go up 4 and then over 3.
Rise every run.
I was just about to say, do you remember Rise Over Run? Very good. Gold star for you. I know this is really hard, guys. All right, let's try another one. 0, 2, 1, 5. Hold on a second.
No.
We're practicing plotting points. And then 2, 8. But you guys do know that Desmos will plot points for you, like if you type them in, right?
No.
Now, that will make a line, but it will not go through the origin. So no is the answer to that one. Thank you. And so there wouldn't be a k value either, because if the answer is no, then it just won't work. All right, and then this one, shush. 0, 0. Okay, so we're off to a good start. It's going to go through the origin. 1, 4.
Yeah.
And then 2, 5. Why is the answer no? It goes through the origin.
Because it's not a line.
It's not a line. Perfect.
Yeah, it is.
Yeah, see, this will make a line, but it doesn't go through the origin. So that's why that one's a no. This one goes through the origin, but it doesn't make a straight line. So it has to be a straight line and it has to go through the origin. Both of those things. Does that make sense? Okay. All right, go ahead and flip over. So now instead of looking at a graph, so these ones, instead of looking at a graph, you're looking at an equation. The equation is y equals kx. You're just seeing if it follows that pattern. Does this follow that pattern? Y equals kx. Yes. So it is yes. And k is -4. Again, k is just the slope.
No.
Why is this one a no? Yeah, it won't go through the origin. It'll go through 0, 3. So you just won't have a constant of variation, like not applicable. All right, how about this one? Y equals kx. Yes, and your slope is 2/3.
Wait, what is it named?
It's called a direct variation is the topic that we're doing. Is that what you're asking? Oh, that means not applicable. It just means there wouldn't be an answer because we said no to the question.
That's not applicable.
Not applicable is what it technically. Whatever. It just means there's not going to be an answer. All right. Now here, and they do this on the SOL. They will have you click on the graph where you want to put points. That's usually how they ask this. So you're going to plot and state 2 more points so that there's a direct variation. What is 1 point that's automatic that you should put on there? Yep. The origin. Thank you. 0, 0. So plot it and then write it. Now you need 1 more though. So can you find another place we can put a point so it'll make a line? Go ahead.
3, -1.
Perfect. Right there. So if you connect those, that'll make a line. So 3, -1. And the constant of variation is the slope. So if you connected those, what's your slope?
3.
Well, you're on down, so it does need to be negative. -1 over 3. Good. So for this one, again, what should be the first automatic point? 0, 0. So put that one because it has to go through the origin. That's the definition of direct variation. And then there are a bunch of different options for this one. Can you come up with 1 other point so that it'll make a straight line?
3.
Well, 3, 3 is already on there. So good. Perfect. -3, -3. Can you come up with another one though? Like, do you know another one? That would be good as well. That's going to go off the grid though.
Oh, one.
Good, thank you. That's the one I was hoping someone would say. All right, so what is your slope, which is your constant of variation? If you connected these. Well, it's going up, so. Well, and 1/1 is just 1. Again, that's what I was saying. 1 throws people off because it's just 1. All right, go ahead and flip to the back. It's not wrong to say 1/1, but you're never going to see that as an answer choice. So do you see how this first sentence is y varies directly as x? Direct variation means it's y equals kx. Hey, Ms. Cole, do I have to write that? Yeah, that's part of the problem. That's what it says. Now, all you're going to do is plug some numbers in. It says y is -15 when x is 5. So you're going to plug in -15 for y and 5 for x. When you go to do your check your understanding, you're not going to have a clue what's going on because this is what the problems look like for one of the sections. Now, what would you do to solve it for k?
Divide by 10.
Divide by 5. Good. Well, you said the word divide, so I was happy, and you're writing it down, so I'm pleased. All right. -15 divided by 5. All right, good. We found k. Go us. Now, here's what you're going to do. You're going to start a second column and plug in the -3 for k right here. So it's going to be y equals -3x. I'm starting over. I just took that -3 and plugged it in for k. Now, hold on a second. Read. What does the question say? Find y when x is 3. So you're going to plug in 3 for x. Close. -9 is your answer. If you're like, hey, I didn't quite get that, we're going to do it again, but you need to listen to me. It says y varies directly as x. That means y equals kx. Do I have to write that? Yeah, that's how the problem starts. These aren't long problems. It's super easy. Get on board, all right? It says y is 18 when x is 15. So you're going to plug in 18 for y and 15 for x. If you just like slow down enough to read the thing, it's going to tell you exactly what numbers to put where. And then what are you going to do to both sides? Divide by 15. So let me share my screen. We'll go to the calculator. I'm going to type in 18 divided by 15. See how it came out to 1.2? So we've got k is 1.2. What you're going to do is start over and put the 1.2 in for k. We found that. Go us. Good job, team. Then I need you to read the rest of the problem. What does it say to do next? If you read, it's going to tell you what to do. Good. So you're going to plug in 24 for y. And now you do have one more step. You're going to divide by 1.2. So let me share my screen and I'm going to type in 24 divided by 1.2. I got 20. It is, if you would listen to me, it really is one of the easy, but you have to write it down. You can't do it in your head, you know? No, I wasn't saying that. I'm just saying you can't just, you know, do nothing. All right, now here's some word problems. The cost, C, so we're gonna have different letters here, C for cost, of lighting a light bulb varies directly with time. The more time you run the electricity, the more what? The more money you're gonna pay. All right, so cost equals K times time. If you want to continue using y and x, that's fine. I just like using the letters it gave in the problem. So C for cost, T for time. All right, so go ahead and read. Can you find a cost and a time? It's going to say it if you just read it. The cost is 15 cents. So you're going to put that in for C.
2,400 at 1,000.
For 1,000 hours.
What's 2,400?
Hold on, we're just not there yet. Now, what would you do to both sides? Divide by 1,000. Now, I'm going to be real honest. If you put that in the calculator, it's going to be a really, really tiny, tiny decimal. So I would probably just leave it like that. There's nothing wrong with 0.15 divided by 1,000. I'm just going to leave it that way. Here, I'll show you. If I put that in the calculator.
No.
Here, I'll show you. What is it? 0.15 divided by 1,000. Do you want to? Well, here we can do that. It's 0.00015 is K.
How many zeros?
3. It's 0.00015. So now you're going to start over and put that number in for K. And then what were you saying over here? Because you were saying the second part of it, it says find the what? To determine the cost if you use the light bulb for 2,400 hours. So you're going to put that 2,400 in for time. And what did you guess for cost? Because you made a guess over since. Okay, let's see if you're right.
That's like.
So you're going to put.
What's the point like what cost? Yeah. 15
36
cents for 1,000 hours. It's 36.
Yep.
If it 36 cents for 24,000 hours. 24,000.
Okay, but hold on. How many light bulbs is that? 1 light bulb. Go home and count the light bulbs in your house and how you leave them on for how long. And also your electric bill is not just the lights. Let's talk about that because this is math in real life. The fan, the refrigerator, the air conditioner, the heater, everything that you plug into the wall. So your electric bill is way more than that. Okay. The oven, the microwave, the toaster, the dishwasher. It's all electricity. The water heater, the clothes washer, the clothes dryer. That's why the electric bill is so much. And they keep raising prices. So it's probably not even accurate anymore. All right. Shh, your voice picks up on this.
Okay.
Last one. According to Hooke's law, this guy, the force required to stretch a spring, do you understand what a spring is? Like a slinky that I had to take away from you? Okay. Varies directly with S. So you're going to have force equals K times S. Well, because it says directly. Then you just read a force of what? There. Okay. So 30 goes in for force. Stretches a spring that is 5 inches. So S is 5. So what is K? Good job. Perfect. K is 6. Now you're going to start over, plug in 6 for K. You just start over. You do the problem twice kind of. Now it says, oh, actually, read what this one says. Can you read? It says write an equation. This is the equation, so that's it. You don't have to do anything else because we wrote the equation.